Hey everyone, thanks for coming to our session. Today we're going to be talking about Snap and their cloud optimization journey and how they've used a combination of tools, including Granulate, to improve their SLAs and reduce their cloud spend. For a little bit about me, my name's Keegan. I'm a manager of solutions engineering at Intel Granulate. I've been here for about 2 years, and we work with companies on optimizing their applications in big data, VM, and Kubernetes spaces to improve SLAs and reduce costs. My favorite customer, bar none, has to be Snap, and I'm honored to be here today with Tom and talk about their optimization journey. Tom, can you tell us a little bit about yourself?
Yeah, my name's Tom Brown, and I'm a senior software engineer at Snap Inc., having been with the company for about 4 years now. I have a range of responsibilities from developing new applications and features to maintaining and optimizing our legacy applications. We'll get into more detail about my team's priorities shortly.
Awesome. So before we get into it, just really quickly what we had for an agenda here today. We're going to start off with what software engineering looks like at Snap, their goals, their responsibilities, their priorities, as well as the challenges that they've run into. We're going to talk about a few different challenges here, including high variance of traffic and raising cloud costs. From there, that's going to kind of bring us into the optimization efforts that they've had to control these challenges, as well as how they leverage AWS to control those challenges as well. That will also bring us into where Granulate fits into that optimization journey, the results that we've seen through our optimization, and overall what's next on Snap's optimization journey. Sound good? Let's go ahead and get started. Cool. Tom, to kick us off, can you walk us through a little bit about what software development looks like for Snap?
I'd be happy to. And before we go into the details of specific priorities for each IT team, developers, engineers, let's talk about the focus of Snap as one of the biggest and most important social media platforms in the world. We have 750 million monthly active users that are loyal to our line of products, which are customer-focused and purpose-built to improve the way people live, interact, and most importantly, have fun. We strive to develop practical products with real-life applications like Snapchat, which is used by millions of people every day.
That's a very large number. I'm sure that brings up a lot of unique challenges. With that in mind, what kind of values do you instill in your team? And I guess in general, what are the guiding principles in Snap engineering?
Snap engineering teams build fun and technically sophisticated products that reach hundreds of millions of Snapchatters around the world every day. We're deeply committed to the well-being of everyone in our global community, which is why our values are at the root of everything we do. We strive to move fast with precision and always execute with the end user at the forefront.
Can you elaborate a little bit more about what kind of responsibilities fall under your purview?
Yeah, sure. Our software engineering team is responsible for designing, implementing, and operating Snap's most critical and scalable services, ranging from user identity services, Friend Graph, and our core persistence layer, and product offerings like messaging, photography, and backend analytics. Everything that makes Snapchat what it is. Our work includes understanding product requirements, evaluating trade-offs, and delivering the solutions needed to build innovative products while applying best practices when it comes to availability, operational excellence, and cost management.
Yeah, that's interesting. So it sounds like you're not only responsible for the development of your applications, but also the FinOps and the DevOps work behind it as well. I'm seeing that happen more and more across our customer base. It's a new trend that we're picking up on, but I'm sure it also brings a lot of unique challenges. Can you mind telling us a little bit more about how you manage these set of responsibilities?
Yeah. To begin with, we have 397 million daily active users using Snapchat on average, and our software engineering team deals with large-scale usage with constant and dramatic fluctuations in activity.
Yeah, I'm guessing with that high user count, it brings a lot of work for your team.
It really comes down to three main challenges: scale, fluctuations in traffic, and growing costs. How do we handle large-scale usage, supporting all those daily users while maintaining aggressive SLAs? How do we deal with dynamic user behavior, which can vary widely between peak and low usage times? And how can we keep our cloud costs under control while our user base continues to grow?
Yeah, I'm looking around, I'm seeing a lot of nodding heads when you list off those challenges. So what are some of the top priorities then from an engineering perspective?
To start with, privacy is our #1 priority. We always ensure user data is protected and handled with the utmost confidentiality.
Yeah, and I'm guessing given the nature of your product and your end user base, privacy is specifically important.
Yes, our flagship product is famous for erasing content after a certain amount of time, and we take that seriously. Just like someone talking to someone in person or on the phone, having a conversation through snaps and chats lets you communicate without automatically keeping a permanent record of everything you've ever said. We don't scan the content to create profiles or show targeted ads. This means we typically don't even know what you're saying or snapping unless you ask us. After privacy, another big priority is scalability. As I mentioned earlier, we develop products that can handle hundreds of millions of users daily, managing billions of requests. Our aim is to cater to a vast user base without compromising on performance.
Yeah, definitely. Scalability has proven to be a really large challenge in the social media space. We hear that very commonly from our customer base. And it's also equally important that as you have this high level of scalability, that you keep the same performance and SLAs behind it.
100%. Our customers expect instant responsiveness and near zero latency, so there's little margin for error. We maintain aggressive SLAs, especially for our priority zero workloads like messaging and the friend graph. It's vital that these services are reliable and always available.
Definitely. The only thing worse than lagging performance is actual downtime.
Exactly. As you said, social media users are not forgiving. They demand stable, consistent, and constantly available access to their applications. So it's my team's responsibility to make that happen. The last priority worth mentioning is establishing an engineering practice. Here we attempt to take a broader view and understand it in the context of the product, the end user, and how they affect those other priorities. This list here is really just the tip of the iceberg, and the big focus is evaluating trade-offs. How do we plan to innovate while minimizing costs? How can we ensure industry-leading performance while allowing rapid user growth? And most relevant to this discussion, how do we optimize our existing applications while simultaneously creating new ones?
Definitely. And what interests me specifically most, you're going to hear me talk a lot about this today, is the scalability and the variability of your end user traffic. I'd be really curious if you could talk a little bit more about why you picked AWS specifically to help with that challenge.
Sure. AWS Cloud Compute powers our core product offerings, and the majority of our workloads are running Go or JVM. These are all hosted on Kubernetes within AWS's EKS platform. For our storage needs, we primarily use Amazon S3.
Yeah, it makes sense why EKS is so appealing to all of you. Can you go into a little bit more detail, though, about why specifically EKS is so viable at Snap?
Yeah, first, scalability. With EKS, scaling up or down is smooth and responsive. Whether it's a quiet Tuesday night or a viral Saturday afternoon, EKS adjusts automatically. Fault tolerance is also an important selling point for us. With EKS, we are able to keep things running no matter what. In the world of social media, downtime is a bad word. Kubernetes helps us avoid that.
Gotcha. So it's kind of like a safety net, where we have this extreme variance in traffic. You can rest assured that it'll scale up with additional traffic and ensure you meet those same SLAs and user experience.
Exactly. And it helps with automated container orchestration. This level of automation means our teams spend less time on tedious tasks and more on what they love, innovating and creating.
Would you say automation is a priority focus for you and your team?
Oh, yes. Pretty much whenever we can responsibly and securely use automation, we jump at the opportunity. There's just so much to do that when we can delegate to autonomous agents and tools with minimal risk, it's an easy choice. Last important thing to note about EKS is that it helps make sure that Snap is resilient, robust, and reliable no matter what. I can't overstate how important it is to have a high availability infrastructure.
Yeah, it makes sense. We see EKS a ton with our customer base, and we actually use it internally here at Granulate as well. But one of the challenges that we've seen coming up more and more is with the scalability and variability is rising or ballooning cloud costs within EKS. Has that been your experience as well?
Yes, and that's why internally at Snap we started to emphasize cost reduction so much. To minimize wasted resources and unnecessary spending on our Kubernetes clusters, we performed every form of optimization we were aware of. These activities included PGO, container right-sizing, cloud discount programs, manual code optimization, observability, tag management.
Can you walk us through them?
Yeah. Let's start with PGO, which is Profile Guided Optimization. For those of you not in software development, PGO is a technique that is all about getting the most out of your runtime performance. By analyzing real-world data, we're able to make informed decisions on how to optimize our code, ensuring it's as efficient and lean as possible. It's broken down into two phases, profiling and optimization. In the profiling phase, We run the application in a production-like environment to collect detailed runtime data. This data includes information about frequently executed paths, branches taken, and functions used. Essentially, it's about gathering insights on how the application behaves in real-world scenarios. You might have heard of premature optimization. This is how we avoid that.
Gotcha. Yeah, PGO is particularly important for me. Here at Granulate, we have an open source profiler. We call it the G profiler, and it collects what functions are consuming the most compute, the system level calls within them. That's a core aspect of our product that I'll go into more later on, where we use that to identify what optimizations are applicable.
Yes, and once we have collected information from the profiling phase, we would begin the optimization phase, where we'd use that data to apply specific optimizations and tailor the compilation process to the application's actual usage patterns, leading to a more efficient and faster executing binary.
Was that done manually?
Yes. This was done manually and could take quite a bit of time to execute correctly. Another best practice we took on was container right-sizing. With a combination of manual efforts and other solutions, we attempted to fine-tune our resource allocation. It's a balancing act, allocating just enough resources to meet our service level objectives without over-provisioning. We'd also do other manual code optimizations, including specific strategies like optimizing algorithms and refining logic in our code base, delving into the nuts and bolts here, examining aspects such as memory usage, CPU cycles, and more to eke out every bit of efficiency. And with cloud governance, we'd find the right policies and monitor consumption constantly to manage our cloud expenses effectively. By governing how resources are used and ensuring we're not overspending, we could keep our cloud infrastructure lean and mean, mostly.
Gotcha. Excuse me. And I'm guessing there's clearly work to be done, seeing how we're standing here today. Is that fair to say? Can you touch a little bit about why these optimizations fell short?
While these optimization techniques were effective in the spirit of persistent innovation and performance improvement, we were continuing to look for cloud cost reduction opportunities. Additionally, it's important to note a key challenge with these strategies is that they're all manual. As effective as they are, manually optimizing rapidly scaling microservice architectures is a daunting task. Each microservice presents a unique set of demands, characteristics, and performance indicators. In a landscape where services and demands are constantly evolving, applying these manual optimizations becomes increasingly complex. This complexity is not just about scale, it's about the agility and customization that each microservice requires. As our architecture grew and diversified, so did the effort needed to manually fine-tune and optimize each element, making it labor-intensive and unsustainable.
Perfect. And I think that's where Granulate comes in. Maybe at this point we can talk a little bit about how exactly Granulate works and why it's complementary to everything that Tom just mentioned. We spoke a little bit about it, but again, as an overview, who are Granulate? What do we do? We're a real-time continuous optimization solution, and in my opinion, we're a very unique company, and we optimize in a way that no other company does. We focus our optimization strategies with our agent solution on two priorities. One is runtime optimization. You can think of the JVM, for example. And the second is orchestration, where you deploy our agent, and aside from the deployment of the agent, there are no engineering efforts needed. Our agent not only identifies what optimizations are available via that open source profiler that we just spoke about, but also acts as a loading mechanism to implement those optimizations on our customers' behalf. It's with these optimizations that we see our customers run with faster SLAs, whether it be latency, response time, job completion time, while having much lower cloud costs. On top of all of this, in my opinion, it's a very quick ROI. After the deployment of the agent, we typically see results, ROI from the agent within 1 to 3 weeks, and we'll talk about exactly how that looked at for Snap here momentarily. A common question I get, though, because as I mentioned, we are a very unique company. We're doing our optimizations in a way that no other company does. The question I get behind that is, when is the appropriate time to adopt a solution like Granulate? In my opinion, it should come later on in the cloud journey. What do I mean by this cloud journey? Well, when we break it down, we really see 4 main phases when folks are adopting the cloud. Perhaps they're going from on-premise to AWS, for example, where the first step here might be monitoring. You might be using solutions like CloudWatch or CloudTrail, where you're not necessarily seeing any cost benefit when you're in this phase, but you're adding observability on where your utilization is, where your costs are coming from. That way you can begin to make data-oriented decisions based off of where we should focus our optimization efforts. From there, we typically see this FinOps practice start to become adopted more and more, where you may use a tool like Cost Explorer, where once you see where these rising costs are, you can leverage some of the solutions available through AWS, such as saving programs, tag management, or a very common theme we see is lifecycle management. Maybe you want to move from on-demand to reserved or spot instances. And this can be really effective going from this monitoring to FinOps, and we typically see a large amount of cost reduction come from there. But we commonly see in our ecosystem that once they reach this FinOps state, it can become gradually more and more difficult to realize where's the next area that we can realize cost reduction. And it's at this stage that we see tools like Granulate come into play. First off here with right sizing. After you have the data about where your costs are, you've implemented FinOps, perhaps it's at this time to ensure that you're properly spinning up the appropriate amount of infrastructure that you actually need. When I speak on here, I'm thinking about auto-scaling on EMR or EKS, for example. It could also be pod auto-scaling, or pod right-sizing, rather, which, by the way, is something that Granulate can help out with, and dynamically adjusting the amount of resources that your pods are requesting so that you don't have high amounts of over-provisioning. Again, here you're not actually going to even realize any performance benefits yet, but these 3 stages can help you realize that cost reduction. And then finally here, this is really where we see Granulate become an effective play for our customer base, is app-level optimization. After the monitoring, FinOps, and right-sizing, with Granulate solution, we first deploy the agent. After activating, you're going to realize performance benefits, mainly within CPU utilization. And then through our runtime improvements and our orchestrational improvements with our solution, we can translate those performance benefits into cost reduction. And on top of that, all of these cost benefits I'm speaking on are on top of all of these other tools and solutions that you've implemented in the past. Speaking a little bit more about what kind of solutions that we can help optimize, we really focus on 3 main areas, Kubernetes, VMs, and big data. Starting off here with VMs, for example, maybe you're running on an EC2 instance. That's where the runtime improvements are going to become the most viable by themselves. And I'll speak a little bit more about what these runtime improvements look like. But when I say runtime improvements, you can think of things like thread pool management, garbage collector, the JIT compiler, and JVM. Where our agent, we can orchestrate how these resources are being used to improve CPU utilization. When we talk about EKS, you can enjoy those same runtime improvements that we spoke on, but we can also help implement our orchestrational improvements as well. I spoke about how with Granulate, we have dynamic pod auto-scaling, or auto right-sizing, rather, where we can scan where there is over-provisioning in terms of requested vCores or requested memory, and make sure that your pods are spinning up with the amount of resources that they actually need. And then finally here, we also do have EMR optimization, or I'll call it big data optimization in general. You can think of Databricks here, for example, as well, where we have a lot of unique capabilities within the big data space, and I'm actually going to hold that off for a next slide where we can go more in depth. So before we talk about, though, how does it work? Let's say you did want to move forward and optimize your application with Granulate. What would the next steps be? Well, let's say you identify perhaps 1 or 3 applications that you're interested in optimizing. You would deploy your agent where it's going to begin this profiling stage. That's where we're going to be gathering what functions are consuming the most compute, the system level calls within them, and we're going to be aggregating that against our optimization library to build an optimization profile, essentially seeing what optimizations are applicable. And that typically takes 7 to 10 days. Once that's done, you can activate, and you'll be here in this optimizing stage, where you'll begin to realize performance benefits, maybe even cost reduction as well, depending on how your auto-scaling policies work. And we also have here capacity reduction to bring in an additional wave of cost reduction, where after we implement these performance improvements, and maybe you already have some cost reduction with auto-scaling, we can right-size your deployments even further to maximize the cost reduction. I do want to call out here that it's not just a straight linear line. We see a circle here in the middle. Even though we do have this initial learning period where you identify what optimizations are available, it's a continuous process. So even after you've been deployed for a week, a month, or a year, we're continuing to gather additional data to identify what additional optimizations are available. It's because of that you can typically see with Granulate that your results will improve over time rather than diminish. And here's a little bit more detail about how exactly that may look within the big data space. We have here on the far left JVM runtime optimization. Those are where those runtime improvements come into play. And our customers very commonly see job completion time improvements from that, where we optimize things like garbage collector, JIT compiler, memory arenas, compression library optimization. And then we also do have two areas on the right here that haven't spoken on yet that we see particularly impactful within big data environments, especially within EMR. The first here is Spark and MapReduce optimization. The second is scaling and scheduling optimization. I'm actually going to abstract this one level higher, where you can think of it as executor optimization and node level optimization. With the executor optimization, it's very common in our experience, especially when looking at EMR environment, for example, that executors are over-provisioned, either in yarn memory or yarn CPU, which results in fragmentation on the worker nodes. We're able to, upon the initialization of executors, dynamically adjust how much resources they are requesting to eliminate this fragmentation, which results in more executors fitting on a given worker node, improving the amount of jobs that can fit on a given worker. And to complement that, we also do have here the scheduling optimization, where it's in our experience when looking at these Spark workloads, that auto-scaling events for scale out will be much too aggressive, and scale in won't be aggressive enough. What we are able to do is dynamically scan a plethora of utilization metrics, such as yarn available memory, available CPU, and job completion time, as well as input size, to more accurately predict when scale-out events should occur. So you're scaling out when you actually need these resources, and more accurately predict when scale-out events should occur so that you can realize cost reduction much quicker. And then finally here, I just want to call it the fact that we at Granulate, we work with both DMBs and enterprise, especially with the recent acquisition with Intel, as we've adopted to those same standards. And we can talk a little bit more on that as we dive into the next slides about Snap's particular journey with Granulate.
Thanks, Keegan. We used many of those solutions and capabilities that you just spoke about to optimize Snap applications. And you also mentioned a few that we're interested in potentially exploring in 2024. It seems like the more you learn about optimization, the more there is to learn. Before I get into how we did it, I want to share with you all some of the results we have achieved with Granulate so you can see where we're headed. As of now, we have deployed Granulate on 350,000 vCores, which has ultimately led to significant cost savings and a reduction in CPU use. These results have made a huge impact, not just on our bottom line, but also on our culture, how we think about optimization, automation, and the hierarchy of software engineering priorities.
I think it's also good to know, how did Granulate become a priority for Snap? I remember, I think it was in May or June of 2022 that Snap had a month-long summit to try and identify what optimization solutions or practices that they can adopt to improve SLAs and reduce cost.
That's right. We have one of those summits every year because optimization and cost reduction is an ongoing effort. But I was not there for that one. So I wasn't there, but my team has certainly seen the benefits that resulted from those decisions. Now, the driving force behind that decision to trial and ultimately move forward with Granulate was automation. As I said earlier, we are actively optimizing our infrastructure with a wide variety of activities, PGO, right-sizing, cloud governance, for example. But those activities were manual and resource intensive. So we went with Granulate primarily because it could automate at scale.
Yeah, and I also like to call out, because Granulate optimizes at the runtime layer, it allows you and your team to do all of those previous optimization efforts as well as new ones in the future on top of it.
Good point. And beyond automation, the other characteristics that we were looking for in a cloud optimization solution were scalability, security, API capabilities, and negligible impact on our response time. Mind you, in this context, scalable optimization means that it is flexible despite usage growth and fluctuations, in addition to being applicable across a variety of microservices. That's what got us interested in Granulate, which was able to bring significant cost improvements through their autonomous runtime level optimizations while maintaining our strict security standards and SLA targets.
So I showed a little bit about how the typical optimization process looks like with Granulate. Here's the more exact timeline about how it looked for Snap specifically. After that summit, and they identified that they want to give Granulate a try, They deployed us on a few workloads where for the first week, we went through what we're calling a cost savings analysis process, where they deployed our agent, and within 1 week, we were able to tell them on a per cluster basis what the expected performance improvements would be, as well as what the expected cost reduction would be due to those performance improvements, allowing us to be transparent up front in the beginning of the process about what the expected value would be. After that, we moved forward with this learning phase, where within 2 weeks, we identified an optimal configuration, activated, and we met together for week 4 based off of the before and after impact on Snap's environment, both in terms of cost improvement as well as performance improvement in terms of SLAs.
It sounded too good to be true, but it didn't take us too long to see the value Granulate could bring. They estimated the savings with their profiler, they backed it up in the testing environment, and delivered visible results in just 20 days.
Yeah, and I also want to call out that the Granulate and Snap teams, we worked extensively together to adapt the Granulate agent to Snap's homegrown control management platform. I think you call it Switchboard, right? Along with incorporating fully into your CI/CD process.
Yes, the challenges at this stage were integration into Switchboard, integration with the RESTful APIs, and observability. It did take a lot of back and forth and communication to reach these objectives, but we ultimately handled those integrations and have great observability into the Granulate part of our ecosystem. This helps us keep track of the agent's health and status so that we have good programmatic control. For every workload that's optimized, we generate an internal dashboard to continuously validate the performance of Granulate. We configure it to run most pods optimized, but retain some unoptimized as a control group. Comparing these two groups ensures that we are able to know what is happening in our ecosystem so that we can continue to realize savings. As I alluded to earlier, Granulate didn't just impact our cloud costs or application performance. It also changed the way we think about optimization. Before, due to the manual nature of the optimization solutions and best practices that we had at our disposal, we were forced to focus our efforts on only the multifunction expansive services. Even if we knew that there was room for improvement, the manual efforts that it would have taken to optimize the smaller one-off functions wouldn't have been worth it. Granulate played a crucial role in optimizing the one-off function services that were previously overshadowed by the focus on multifunction expansive services. By bringing these under the Granulate umbrella, we have ensured that even the smallest functions contribute to the overall efficiency and cost effectiveness of Snap's operations. To optimize just 1 or 2 of these less expensive services would not have moved the needle, but with Granulate autonomously and continuously optimizing a large amount of smaller services, the savings are significant.
That's interesting. So on this concept of automation, you're able to use Granulate's agent to implement these optimizations so that you and your team can focus your time on others type of optimization strategies.
Yes, these code inefficiencies and bottlenecks can become pretty problematic, especially in containerized environments like Kubernetes. So to have attention paid to all of the services, not just the massive ones, can be quite impactful.
And that's what really makes EKS such a great use case for Granulate. While it does indeed bring great value in terms of scalability and stability for dynamic applications, it can effectively become a cost issue. And when you add Granulate to the equation, the scaling capabilities of EKS become a major benefit here as we autonomously implement these performance benefits, and the Kubernetes autoscaler will begin to scale in to realize those performance benefits into cost reduction. I also want to call out that Granulate was built with a focus on our integration into AWS with the ability to really optimize all of the major platforms within AWS, including VMs such as EC2s, Kubernetes such as EKS, as well as big data platforms such as EMR and EKS, as well as Databricks. Additionally, I want to call out, due to Granulate's continuous and autonomous nature, DevOps teams can rest assured that anytime you're releasing a new update to your application, could be a new deployment, a new function, whatever it may be, that you can release this new functionality without seeing a sudden rise in your cloud costs. I also want to call out here that you can find Granulate on the AWS Marketplace.
So as of September, Intel Granulate has been deployed on 350,000 vCores, providing an average of 13% cost reduction across 32 clusters, and we have more in the pipeline. As you can see from these graphs featuring Granulate's dashboard, the CPU utilization was reduced by as much as 35% on some of our clusters, and we were able to eliminate the need for 1 in 7 cores when the optimization agent was activated.
Perfect, and we're just getting started, right?
Oh yeah, it's been such a convincing experience that we have big plans when it comes to optimizations. As you saw from Keegan earlier, Granulate has a compelling offering when it comes to big data workloads and capacity optimization. And offloading this to Granulate will free us up to work on other optimization fronts.
Perfect. I'm really excited for that. The big data space in general is one of our bigger use cases. Could be EMR, Databricks, really any Spark or Hadoop-based workload. Perfect. Well, we're going to be sticking around a little bit longer if anyone has any questions or if you want to go a little bit deeper in anything. Really appreciate your time. Really briefly, we do have a couple of other sessions coming up as well. One with Netflix here. The other is regarding AI acceleration at the edge. You can also come join us at our booth or connect with one of our partners here as well. Thanks, everyone.